So we will talk about, the Terraform and Terragrunt, like on the infrastructure as a code today. That what it is all about, how it is, why it is important, what all things we need to do with this and other stuff. Now, the point is that, this all is the infrastructure as a code. We have to provision the resources, we have to provision the servers, on the cloud. These days, everything is running on a cloud. And for that, if we have to spin one server, two server, you can do that manually. You can manage that manually. You can handle the things. You can do the stuff. But when it comes to the larger infrastructure, right, where you have hundreds of servers running in, you have a different VPCs, you have a different other resources. You have to create the S3 bucket on a daily basis, right? You have a multiple AWS accounts, multiple AWS environments. In those kind of scenarios, it is important to have some code maintainability, right? Some process, some logic to be set up, which basically help you to manage the things. On the same note, right, we have a Terraform and Terragrunt, right, which basically helps you to uh, achieve all of the things, right? Whatever the things we want to achieve with that. Okay. Now, when I say this, right, so with that, we will like all of these, as we said, right, that this comes as a part of the IaC, right? That okay, it all is the known as the IaC and the things. So normally, if we see right at what problem uh, Terraform and Terragrunt will solve for us. So if we will see that, right, so Terraform will always solve the infrastructure as a code problem. What it will solve? Infrastructure as a code means it is going to give us the IaC part. The second part is that you can declare the provisioning of the resources and of the cloud resources, right? You can declare the provisioning of the cloud resources with this, right? So that is one of the another part, which we can resolve here. Another important part is that this is state driven, means it maintains the state, whatever the files which are getting changed, whatever the things which are getting changed are adding up here. So it maintains the changes for those, and you can work on the, like you can basically tomorrow if your state files are not like let's say state is not maintained, or you have to get back to a particular state. So using those state files and things, you can get back, right? This is a reproducible infrastructure, means you can reproduce the infrastructure with the help of the state files, or the with the help of the particular code. Now Terragrunt, in a nutshell, in a small terms, Terragrunt is nothing, just it is the wrapper on top of Terraform. It is what? The wrapper on top of Terraform. It helps you to solve the repetition. Okay, whatever the repetition and whatever the repetition are happening, right? Whatever the environment related sprawls are happening, it will help you to solve those problems, right? And also it will help you to do a dry run, right? Now, more than that, it will help you in managing the remote state automation. Means you have to sometime, we have to do the state automations, and we have storing the state automations in a very different way, the state files. So we'll talk about that in detail. And there are a lot of dependencies which we have to manage. So it will help us to achieve the same. And as I said, that when it comes to multiple environment, right? So it will also help you to manage those multiple environment, means cleaner multi-account process will be there, or multi-region setups will be there. So these will be our good process here. Okay. So in a very small terms, Terraform is what? It will define what to build. It will define what to build. And Terragrunt is what? It defines how it's organized and reused. Okay. Any questions here so far?
No. No, Sachin.
Okay. So this is a simple understanding or a difference between the Terraform and Terragrunt, right? Now, definitely you can provision the cloud resources using three mechanisms, right? The very first itself is GUI or the console, right? Using the AWS console, Azure console, or whatsoever it is. The second method is the APIs, right? And the third we are talking about is the IaC. The second method is APIs, means you can have the APIs and the other things, right? So IaC is what it basically represents the transformative approach to infrastructure management, means where you can define and manage your entire code, right? So in terms of really, okay, what is IaC? Okay, if we define in terms of O'Reilly definition, so this is IaC, right? Where it says that you can IaC represents a transformative approach to infrastructure management, allowing you to define and manage your entire infrastructure through the code. This methodology ensures complete transparency and control over the infrastructure, providing an accurate overview of your environment at any given moment. Okay, mean you will able to understand, you will able to see the everything here, right, in a nice and concise and clearer way. Okay, so this is all a this is known as the IaC. There are also sometimes there were some tools, known as the Ansible, Chef, Puppet, right? Those configuration management tools are also part of the somewhere category of the IaC tools only, right? But uh, they have to configure the machines, right, to exact specifications, right? There are some server templating tools like AMIs, AMIs and all also do what? It includes the OS, whatever the software and whatever is configuration needed, all those things, right? Orchestration, you'd see Kubernetes. Kubernetes does what? It manages your deployment, scaling, right? And the container applications across the servers, right? So, and this IaC is what? This comes under the provisioning tools, right? So, if I have to give the diverse category of these IaC tools, right? If I have to give these diverse categories of IaC tools, probably I will try to fit that into this. One is ad hoc scripts, right? Means you can have a ad hoc script through which you can automate the things and steps to process to provision your infrastructure. Then it will be configuration management tools, right? There will be the configuration management tools, like I said, Ansible, like I said, the Puppet, Chef, and other things. Then you can have the server templating tools. Example, AMIs, right? You can use the AMIs and things which will include the OS, which will include everything to automate the stuff, right? And then we will have the orchestration tools. For example, you will have the Kubernetes, you will have the uh, which will help you to orchestrate or to automate your deployment, scaling, and manage your containers. And the last comes the provisioning tools, where the Terraform and comes into the picture, right? Where you can use that. Now, there is also, one more tool known as Pulumi, right? There is also known as Pulumi. So Pulumi, right? Which is again the uh, part of the Terraform. So the point is that again, these are the cloud agnostic tools, right? Cloud agnostic tools means you can use these tools are like there are some tools which are based on the specific cloud platforms. So when you talk about the category of provisioning tools, okay, for example, so that basically depends, or that basically takes care of two things. The first is the cloud specific tools. Okay. Now, cloud specific tools means which are specific to the cloud provider. For example, AWS provides AWS Cloud Formation. Okay. There you write the code and the things into the AWS uh, Cloud Formation, and that will help you to put up the things. Disadvantage with this is that it doesn't have a state file management, right? It doesn't manage the states or these things. Like Azure also has the same thing, which you call it as a Azure Resource Manager. And Google also has the same thing where you call it as a Google Cloud Deployment Manager, right? You call that as this. So means each cloud vendor has their own specific things, right? Which provide where you can integrate with the different things and stuff. But there are certain disadvantages to that, right? Where like it doesn't support multi-cloud, it doesn't have a state file and other sort of things. Now there would be something known as the cloud agnostic tools. That means there is something which is specifically designed to stand out in this category, right? So there comes your Terraform, right? There comes your Pulumani, right? And other things. Now again, there would be a lot of other things in the market, right? These is Open Tofu and other things are also doing this stuff. So it depends, right? What exactly you want to do or what exactly you want to achieve. Okay. So this is all about the things. Now, as I said that it is cloud agnostic, that means it can be compatible with many clouds, right? Not only with AWS, but it can be compatible with Azure, with other services and other cloud vendors too, right? We often use, as I said, Terraform with the in the conjunction with other DevOps tools. For example, you can use it with also you use the Kubernetes. You can also add some custom scripts in that. You can also add Ansible and other things. And there are some packers, which are helping you for server templating and things. So with help of all those, also you use this Terraform to achieve end-to-end provisioning of infrastructure and applications, right? So the architecture overview of Terraform is very simple, right? Means which will in a smaller terms we will talk about it. Okay, how does that really work? Really work, right? So at the core, right? At the core, Terraform operates through something known as a Terraform core. There is a Terraform core. Now, what does Terraform core is, right? Or how does that work? So Terraform core is a powerful engine, you can say, right? It's a powerful engine. Okay. So for an example, one second. Yeah. So for an example, if we talk about, the things here, it is one of a engine, which will help you to process all the config files, right? It's a powerful engine, powerful engine that process all the configuration files, right? Now, that process all the configuration files in a very simple terms is that it will all the state files, all the other TF files and things which are there, those. It will interact with the cloud provider's API, right? It will interact with cloud provider's API, right? Because it has to spin up the resources in cloud provider. So it will interact with that and ensure that align our actual infrastructure with the desired state. Means whatever the state we want to put into the actual infrastructure, so it will align with that, right? Now this definitely, this all of this is achieved via the providers, right? There are the providers in the Terraform which you write. So this is achieved via the providers, right? Which, like example, you have the AWS Terraform provider, you have a cloud provider, right? So AWS Terraform provider, right? Or example, Cloudflare provider. So now in the Google, if you search right here, AWS Terraform provider, right? So you will see that you, as you have a Docker registry where all your Docker modules and images and things are stored. Likewise, we have a Terraform registry where all your Terraform this providers are stored. So if you see that this is your AWS provider, if you have to use this, you can just simply copy this, right? You will see that okay, there is a required provider. This is the version 6.0 is the one, right? It is used with the Terraform 0.13 and later versions. And to configure the provider, you write the name of the provider and you give the region where you want to access. And then you define the resource that, okay, this is the resource you want to create. EC2, VPC, S3, what are those? They are the resources, right, of AWS. In AWS, they are services, but with terms of Terraform, they are resources. So you can define the resource block and there you can define all the resources and things whichever you want to create. Okay. Now, likewise, you can define the provider with the access key and the secret key for authentication and other purposes. So, like this, the things get changes as and when you move ahead with the session name, the role or ARN, whatever the way you have to assume the things, whatever the way you have to pass the things, right? So that goes on further. However, for now, in a nutshell, we understand that okay, there is other providers which helps us to create a connections, right? Which basically serves as a, so this is going to do what? It's going to serve as a intermediate boundaries, right? Between the cloud and the Terraform, right? Now, in a smaller terms, if you understand, this is going to be very simple. There will be a developer or there will be some continuous integration job, right? Which will trigger the things. Those things has to end of the day run via the Terraform CLI, right? You are running it via the Terraform CLI. That will call what? It will call your Terraform core, right? And this Terraform core in return will call providers, right? That is your AWS, Azure, GCP, right? Even the GitHub providers as to run via the GitHub, whatever it is needed, it will do that, right? And also, it will call the backend to ensure that your state storage and whenever Terraform executes, it adds the lock. So this locking is happening. Okay. So this is the flow through which it will run. Any question here, guys?
No.
This is the architecture smaller overview in terms of this. Means when I run this Terraform CLI, so that is nothing, that is my entry point commands. You would have heard that we run to run the Terraform code, we run Terraform init, okay? We run Terraform plan, right? And we run Terraform apply. These are the three commands which we mainly run. Init will initialize the Terraform. It will initialize the Terraform, and as soon as it will initialize the Terraform, right? As soon as Terraform init will initialize the Terraform, will initialize the Terraform, and it will create a log file immediately. It will create a log file, okay, known as, let's say, .terraform .log.scf, okay, as it's mainly written by the HashiCorp or language, so it will be the SCL format. Terraform plan will do what? It will show you the plan. It will show you the plan. Okay, it will show the plan that these resources are going to be modified or changed or deleted. Modified or changed or deleted means before even I apply the things, run the Terraform plan and ensure that yes, I am good with the things. Okay. Terraform apply will do what? It will apply the final changes. Sorry, it will apply the final changes. Okay. And there would is another one known as a Terraform destroy. It will destroy all the changes. It will destroy all the changes. So this is all what the Terraform mainly do, right? This is basically used by all the developers in the locals or any CI/CD pipelines and things. They all do the same thing, right? This is all the stuff, right? All the Terraform configuration, right? All the, I would say this is your first entire thing here. Now the second entire thing would be your Terraform configuration, right? All the second Terraform configuration which is there, right? That you write in the HCL, that is in the .tf files. Okay. It contains your providers, your resources, you write the modules, you write the variables and outputs. Okay. As I already showed you, right? That in the example in this registry, that how you write the providers, you write the resources and other things. We'll talk about all those in detail, right? Now, yeah, here to conclude for Terraform core, right? It reads the desired state and current state, builds dependency graph and creates an execution plan to execute the plan via the providers. This is in a smaller terms the Terraform core does. Okay. This is what your Terraform core does in a smaller terms. Getting now, let's talk about these each resources, right? The providers. What are the providers? Now, Terraform providers are what? This is an execution layer. Okay. This is what? This is an execution layer, I would say. Okay. And the providers are the plugins. Providers are the plugins. Also, this is an execution layer. As a gameplay example, you can have the provider for the AWS, you can have the provider for the Kubernetes, you can have the provider for the GitHub. Okay. Terraform provider will translate those Terraform actions into the API calls and apply the CRUD operation. CRUD means what? It will create, it will replace, it will update, it will delete, right? Create, replace, update, delete. So the Terraform also do the same. It will create either it will modify or replace, either it will update something or it will delete or it will destroy something. So Terraform will apply. So these providers apply the real CRUD operations on the real infra, right? Now tell me one thing. There's a question here. Does Terraform talks directly to the cloud APIs? Now with this understanding, the question is that does Terraform talks directly to the cloud API? Guys,
It just tells the providers that Hey, the user has requested for this piece of
Exactly.
file.
No, it is the provider which talks. Providers which talks to the cloud APIs, not the Terraform. Right? These are the plugins which talks to the cloud API. Right? This now another important concept which we studied, right, in the terms of the Terraform terminologies which we are reading right now. Right, Terraform terminologies I would mention here. So this is all about the state backend. For example, consider, in a very smaller terms that you have a developer and that developer have, all the Terraform config. You have a provider, data sources, backend, variables, output, every TF file you have. You trigger it via the, you have a multiple providers and things. When you trigger it via the Terraform, you will have the state files, right? The state files will be storing some of the state, right? Known as a, it will be stored in the form of this .tf state, okay? This way. So once you have the state file, right? This state file will be you store the state file either in the S3, right? In terms of AWS, in terms of Azure, you store it in the Azure blob storage, or in the GCP, you can store it in a GCP storage, right? So, or again, there are a lot of other, there is one enterprise good paid version of Terraform comes known as a Terraform Cloud also. So there also you store there in the there itself. So the state file will be stored at a multiple places, right? This is in a so this is the source of truth, right? This is the source of truth that what has happened with the things. What this will store, right? What this will store. This will store this state files will store the following info. It will store the resource IDs. Whatever the resources we are applying for that, each unique ID will be there. It will store that. It will store the metadata. Okay, whatever the metadata information is there, it will store that. It will store the dependencies, and it will store the dependencies, and it will have the drift detection rules. Means drift detection data, in fact, means if there is any drift happening between the states. For example, there could be happen, right, when the state files gets into the lock state. Okay, why they get into the lock state? Because two people are trying to update the same resources. So now Terraform doesn't know that which change is the real change, yours or mine's. Okay, so that is why it is there. Now when we say the Terraform state file, right, there are two types of this. Again, the first is the local one, right, which is the default one we create, and that is unsafe. And the third one is the remote recommended, which we store in the S3 and the other places that we are calling it as a remote, right? So common remote backend which we provide is the same way, right? So we do use one of the S3s to manage the state. The state files we put there, and if any lock happens or log and other things goes on, so that we manage from the DynamoDB. Okay, so log files and those things we manage from the DynamoDB. State file is very important part, because this is the place from where you compare your desired state versus the actual state. Without the state file, the Terraform is blind. Without the state file, the Terraform is blind. Okay, so it is not good. So this is all about the state file, and the providers we have already talked about. Then we have talked about Terraform init already, right? Which it downloads the providers, configures the backend, initializes the modules, and initializes the Terraform to run the plan and the apply. So in another terminology, if I talk, right? So Terraform init will do what? It will basically help me to downloads providers, configures backend, and initializes modules. Okay, so this is what it does. When we talk about the Terraform plan, right? It will do what? It basically reads the state. Now it runs very simple way, right? You just write this Terraform plan. This is a command to run it. Also to run this, the command to run this is very simple. It writes the Terraform init. Now this is going to Terraform's read state. This will query the real infra, right? And it creates the execution plan, right? Again, either it will, whatever the execution plan is, create, modify, or destroy, it will do that, right? No changes are going to applied here. Okay, remember, no changes will be applied here. Okay, that is important part to note. Terraform apply. This you again run how Terraform apply. This is a simple command you put. Now this executes your plan. Sorry, this executes your plan. It will call your provider, which will talk to the cloud APIs. It will execute your plan and it will update your state. Okay, it will update your state. This does everything, right? And the last one is a Terraform destroy if you want to destroy anything, right? Now, the Terraform also builds the, the DAG, the dependency graph architecture. So let's talk about that. Terraform builds a directed acyclic graph too, that is known as a tag. Okay. Sorry. Now, when I say it does that, that means it will benefit us in parallel execution, to ensure that the things are deployed in the correct order, right? For example, when you are creating a EC2, right? Now, help me understand, according to you, every one of you would have created the EC2, right? What would be the correct order to deploy the EC2? Guys?
Just create the EC2, right? I mean,
But there would be some dependency components you need, right?
while creating the EC2, we select the name, the security groups, and all that stuff, right? The user data, AMI.
Correct. So that means VPC and everything, right? So means VPC is your dependency component, right? If you don't have a VPC, if you don't have a subnet, if you don't have a security group created already, or you don't have that defined already, how will you select those in the EC2, right? For example, your VPC is not created. You don't use a default one, right? Normally in the enterprise, but you use the other one. So when you define that, so for that, if your VPC is not created, if you don't have a VPC ID, you are, let's say you are creating EC2 via console. So you will do what? You will just hold off, right? And then you will again first create a VPC and then you will move ahead further with the other things, correct? Not getting.
Yeah.
Okay. So likewise, help me understand that if you have to create a VPC, then what will you do?
Uh, Again, same thing, right? Like configure the subnets.
Exactly. Configure the subnet. Then you will have a security group. You will have the any NAD configuration, EC2 ruler. Sorry, not EC2. Any VPC, like the rules, the target groups, and other things. All those things you configure. So dependency, this graph architecture, right? The Terraform, what does it build? That follows the same thing. It will execute the things parallelly. Means if you have the VPC EC2 greetings, it will ensure you have the VPC or not, right? So you will sometimes you will get the errors in a way so that it will help you to understand that okay, when you will think that oh, now it is building or it is getting the issues from the dependency components, right? So that is what it follows. Okay. Now the another important part is the module infrastructure, right? Modules are nothing. So also it has this thing, known as the modules architecture, Terraform. Module architecture is nothing. It is basically your scalability layer. Consider modules as your functions, to be very honest. Okay. Consider modules as your functions. Now, think of this, right? That you have a different, Route 53, you have a different hosted zones, load balancers, network ACLs, and other stuffs, right? And for each of them, if you don't create a module, right? If you don't have a module and the things, so what will happen? Like, for example, every Terraform code, okay, the every Terraform code, it which you run has one root module. Okay, it will have one root module. Modules can call the child modules. Modules can call the child modules, and modules are versionable and reusable. Example, I'll tell you the example module Terraform. You see this, we have a different Terraform AWS modules. For example, we have a module IAM module, right? You will use this particular IAM module, you will use this particular version IAM module, this, right? Like this, you will define this is the module, this is the function known as the name IAM. The source is Terraform AWS, IAM AWS, and this is the version. Now, this IAM has what? You create a IAM user, for example. So you will use this IAM sub user module. Means you don't have to define the things again and again. You will be using the same stuff. Example, again, if I go to the parent module, IAM module, right? So if you use this to create an IAM account, to create an IAM role, you will use a module IAM, define the source, and you start defining the things that, okay, these are the stuff, these are the condition which is needed. To create a group, you will start defining that, okay, to create a group, these are the policies, these are the things needed, right? To create an IAM policy, you will use module known as the IAM policy, and you will start defining that okay, this is coming from this source of Terraform, and you will start defining your IAM policy, right? That okay, this is IAM policy which will allow the describe of EC2 instances for all the resources. Getting why what is the use of the module?
Yeah, like a function that
Function.
you can call
It,
from a main method.
exactly like a function you can call with a main method and things. So this is about the modules, right? This is all the modules where you can like it's like, multiple resources and things you can use it together, right? It consists of different multiple packages or multiple resources which we can reuse. Now, we also have, the different like different if blocks, different count blocks, and the for kind of a conditions too. It is not recommended to write all of those things, right? There is a question, which comes sometimes, that what is the difference between the Terraform count versus for each, right? But I would say, that it's better to less use all of those things and put the steps. Why will tell when we'll do the code part in the things, right? But let's consider, the things, in terms of the simply, other understanding now. Means how does the code structure and things should look like? How does the repo structure and things look like in the Terraform? When I talk about the environment architecture, right? Means without Terragrunt, if you have to put any things. Okay. Without Terragrunt, when you have to put, so for example, you have this Terraform as a repository. Okay. This is your directory structure. Now, with this directory structure, right? If you will see, right? Uh, so you will have the dev here, right? Let's say there will be the architecture for the dev. And then again, for this dev, I will have the folders here, right? I will have the folders here known as, or files here known as the main.tf, right? This is going to be my main.tf file. Then I will have the example variables.tf, right? And for example, then I will have another file known as the backend.tf. Hmm. Means I have a different files and the things. Likewise, I will have a folder here for the staging, right? And likewise, I will have a folder here for the prod. Okay. Means with this architecture of Terraform, can anyone help me to understand the problems here?
You have to replicate the stuff for different environments.
Very good. Means we are doing the code duplication part, right? We are repeating the backend again and again for the different environments. Okay. And with this, the risk of the drift, with risk of the state file drift will increase. Correct?
Yeah.
This was the problem. This was the problem actually with respect to the Terraform architecture, which is solved. This is solved by the Terragrunt. Okay. This is solved by your Terragrunt. Now, the same architecture, the Terraform part, we apply in the Terraform CI/CD architecture too. How? There would be the pipelines, right, which will do everything and stuff. And when the code is pushed, right, so the Terraform backend is what? Backend is your state files, right? S3 bucket and DynamoDB and those things. And let's say you create the resources and the things out of that. Okay. So whenever the pull request and everything will happen, this, so example, we have said that, okay, whenever the git commit is happening, right, you trigger the CI pipeline. Now the CI pipeline will do what? It will be spinning my Terraform resources. Now don't directly apply the init or don't directly apply the things. Means there would be multiple developers writing the code, man. So you should check that whether the code, whether the syntax and the syntactic semantical things are right or wrong. So you write Terraform format, that is FMT. Then you write Terraform validate, means you check if the code is right or not, right? The syntactical, the things are good or not. Then you run this init, then you run this, plan, then you run this apply. But don't run all the things in one go. Means Terraform FMT, that is format, Terraform validate. These will be your mandatory steps, for example, right? Or basic checks. Now make a habit. For example, you have written a command code, Terraform code.tf file. Before even doing a push to the git command, you only check Terraform FMT. Terraform FMT will do what? It will automatically format the Terraform code. It will automatically format the Terraform code for me. Now, you write a GitHub workflow, or you say a Jenkins job, which will basically, let's say you write a validate plan, right? Or you say apply Terraform, or not apply, you say run Terraform plan. For example, anyone, if the PR is created, right? When this will be run, once the PR is created, the pull request is created, run the Terraform plan first. Means before merging to the main, you run the Terraform plan. And then you will be having GitHub workflow. Okay. Let's say you name it as apply Terraform example, right? Or run Terraform apply in a more simpler way understanding. This you run once the PR is merged to main or changes are merged to main. At that time, this should be triggered. Getting it? There's a flow of everything, right? Terraform apply will run, but you run it once the things are getting merged to merged to main. So that all the changes of the main and the things will be there, right? You should use OIDC for authentication. Okay. You should not use the secret keys and access keys. You should use the OIDC and things for the authentication. Okay. Always apply only from main. These are some of the best practices. Plan on PR, right? Means if I say the best practices for the Terraform in the CI/CD architecture, best practices for the Terraform in the CI/CD architecture. This is very, very important, guys, right? This is the first is plan on PR only. Okay, means run TF plan on PR only. Okay, run TF apply only from main. Use remote backend. And the last is use OIDC for authentication. Getting it? Does this make sense?
Yes.
Another important implication which we don't follow sometimes and we tend to do mistakes is in terms of the security architecture. Means no secrets should be stored in the code. Either you put it in the GitHub secrets or in the AWS secrets manager or in the another HashiCorp or Vault or any other thing. But no secrets in the code. Okay. State encrypted. The state file should always be encrypted so that it should not be readable by other people. Follow the least privilege IAM policy. Whatever is needed, give that only. Don't give more than the other thing, right? The person is not your friend. The person is not your rishtedar, right? The relative, where you have to give anything so that he will treat you well, right? It's a security implication. So give it the least one, whichever is needed. make sure that the log state and things are also implemented, so that state file, as soon as you run, the state file is logged until your process is not done, until your TF apply is not done. The state file will remain in a log state, so that two applies doesn't run at a same time. You don't, on the same repo, on the same resource, two apply don't run at a same time. That's where the TF lock and other things, that's why TF lock is in the picture, right? Because if you will not do the state lock, so it will try to apply the two resources. Let's say they both are running on the same, there will be the conflict, right? Normally, state files are or encrypted and stored in a S3. DynamoDB has a locking enabled, and Terraform runs with an IAM role. Okay, this is all about the things. Nowadays, there are a lot of demands. Like, okay, you are scanning the uh my code. I'm writing a Java code, I'm writing a Python code, and you are doing the code scanning. So why don't you scan your DevOps code also? Why are not you are not doing the IaC scanning also? Getting it? So IaC code scanning tools, right? This is also coming in the demand, right? That why you are not doing that. I think, which is to some extent very important, right? Because to detect the security vulnerabilities, the code quality issues, and the misconfigurations, part of DevSecOps now, right? So you can integrate it with the CI/CD, with your IDs and other things with the steps. Now, definitely, there are some SaaS-based tools, that is static application security testing tools. The code scanning example, the SemGrep, right? The SemGrep is one of the tool, right, which will help you to perform the static analysis, right, and these things. But these are the tools which does for the normally for the Python, JS, Java, Go, and this, right? Then you have again the code QL. This is also uh, the tool, to find the vulnerabilities, right? To find the vulnerabilities in the code, right? Now, but there are a lot of other codes too, right? But we want to here do, we want to check for the Terraform, right? So any idea that what can help us to do the Terraform code scanning?
That's the same thing that we used for Java. Help.
No, that will not help actually. There are the different tools designed for the static analysis for this. For example, for IaC, that is the CheckOV. Okay, CheckOV is one of the tool which will help you to define for this, right? Which will detect the misconfiguration in Terraform's cloud formation or this thing. This is an open source one, right? There is another one, which basically known as a CubeSec, right? This is will scan your Kubernetes manifest scanner. Okay, this will scan your Kubernetes manifest scanner. It will score the configuration vulnerabilities in the Kubernetes in the K8s manifest, right? There's also, the scanning tool known as a Git leaks, which will help you, which is basically the secret scanner for the Git repos, right? It will scan your, detects your the hard code keys, the passwords, the tokens, anything in those stuff. So yes, so definitely, when we talk about the tools, so definitely for general code security, you use the SonarQube normally, right, and other things. For the uh, IaC scanning, you can use the CheckOV, and we can use the CubeSec for the Kubernetes manifest scanner, and CheckOV for the static analysis for the IaC. And for secret detection, you can use the Git leaks. So these we can integrate with our IDs. This we can integrate with our uh, CI/CD checks. We can write in the GitHub actions, and if any high severity anything will be there, it will just fail. Okay, got it. So this is one of the important part here with respect to the code security scan, which is important to implement. Right. Now, how to install Terraform, right? To install Terraform, like, it's a simple process, right? If you are using Mac or something, right? So you can just go ahead and you can install using a command brew install Terraform and other things, right? But otherwise, on any other Linux or Windows or things, you can install the Terraform just using this package managers, right? You can, as I said, right, you can use brew install Terraform and that will do that for the Mac OS. If you want to do a manual installation on any of the operating systems, right, not only Mac or Linux, but even on the Windows, so it says that you have to just you have to copy this downloadable links, right? From here you can copy this appropriate zip archive, and this package manager will help you to download the package. So using this, you can definitely download the Terraform, you can install the Terraform, and once you have installed the Terraform, after that, install Terraform, and so you can verify, verify once installed, verify using Terraform minus version. So this will give you that, okay, the Terraform has been installed or not, right? So this is about the more about the Terraform state, right? Terraform installation part.